Hello everyone. This is the second lesson of the circle properties. Okay, so the previous lesson we did the very basic stuff. Okay, so arc, chord, and the center angle. In this topic, we're gonna nuance the angle at the circumference. So what the angle of the circumference is, whenever subtended from same arc, okay, there will be center angle and then angle in the circumference. Okay, so they are double or single. Okay, so this one is one of the very widely used theory of the circle geometry. So you shouldn't miss this one. Okay, so it's very readily used. So what's happening here in the arc here? Okay, the same arc can produce the angle to the center and can produce angle to the circumference. Okay, so this angle in the center should be double of angle which is subtended to the circumference. Okay, but make sure subtend from the same arc. Okay, so this x may be anywhere, can be anywhere. So like this one, if this is x, still x. If this here, x. Anywhere it is x. So single, double. Okay, so that's what we have to understand. Okay, let's move on to the question to see what we can do. Question 7 here, look at this one. Prove, this question 7 is basically the proof what the theory is. Okay, so we're gonna, it's not really a question, it's kind of prove what I just told you. Okay, so what's happening here? Angle AOB, okay, angle AOB is double of angle ACB. You get me? Okay, so if this is double, this is single. That's what we're going to, this is exactly what I told you about a minute ago, angles in a circumference. Okay, so double and single. So how you do, there are a little bit trick. So let's say this angle is x, let's say this angle is y here, okay? What's happening here? Well, in the triangle OAC, so they are two radii, so a triangle OAC is an isosceles triangle. So you can say this is x. Can you see this? We name this angle OAC is y, then this should be y. Because this triangle is also isosceles triangle. You get me? Therefore, we can say this small angle can be rewritten y minus x. Can you see? Okay, that's y minus x. Now, can you see here? X and x. So this x is the exterior angle of the triangle. So you can say 2x. So that plus that must be this exterior angle of the triangle. Can you see? Also here, also you can see y, right? And then what's the exterior angle? This is the exterior angle. So that plus that should be the exterior angle over here, which is 2y here. Can you see? Now, as you can see here, that angle can be represented by 2y minus 2x. So that is right, 2y minus 2x here. So look at this one. The angle AOB is 2y minus 2x. The angle ACB is y minus x. So that's double, that's single. So that's the result. Get me? So this is a basic theory, okay? Basic, theory and the big picture of the question, okay? So guys, start writing. Okay, your first step is to name those two angles, so the x and y. Well, there may be something else, okay? But please try this way in this case. So OAC is x, and then OBC is y. Just name them. And then angle OCA is x, okay? Angle OCA is also x. The reason is two base angles of the isosceles triangle are equal, okay? Base angles of two base angles in the isosceles triangle are equal. Now, what is next one? XOA. So XOA, this angle is exterior angle, which is 2x. So that plus that is 2x, okay? Similarly, you can say OCB. Okay, OCB is y. So this is y, right? OCB is y. Reason, isosceles triangles, the base angles of this triangle, this isosceles triangle, the same. Y and Y over here, Y and Y. And then exterior angle again, XOB, so that equals to 2Y, because Y plus Y is this Y. That's the exterior angle of the triangle, okay? Then what you can see, AOB is XOB. Well, anyway, okay, say XOB minus XOA. So this angle can be obtained this minus this. So you can say 2y minus 2x. So that equals to 2y minus x over there. Okay. Next one is angle ACB. This triangle is y minus x, as I spoken to you. Therefore, we reach the point of the conclusion. Understand that? Okay. Again, yes, there must be some other possible way in solving this question, but make sure this is just one of them. Okay. Okay. So that was question 7. Question 8. Question 8. Find x. Find x here. Okay. Okay. In having this question here, when you just learn about, okay, what have you learned about here? Whenever you have here, say like this. Okay. So this is double. This is single. Okay. In other words, if you have another circle here, whatever that is, okay, so that is double. So this minor arc produce this reflex angle, and this major arc produce the circumference angle over here. So double, single, double, single. Therefore, the reflex angle here will be double of this angle. That's how you do. Make sense? So how you do? Well, that's 146. So this angle should be 360 minus 146. Okay, and then divided by 2, then you'll get x. That's how you do. Okay, you may be able to predict what the answer will be for this question. Okay, reflex angle POR equals 360 minus 146, which is 214 here. And then the angle that we want to find out is 107, because half of this one. Okay, so x equals 107. The reason angle at circumference is half of the angle at center. Okay, which we find out. Okay, so that was question 8. Easy. Okay, we do question 9. Question 9, find x, y, and z given. Okay, AB and OD are parallel over there. What you can do, well, the easiest one first. What is the easier one? Easy. Y is easy. Y is easy, because they are alternate angles. Can you see that? Because they are parallel lines, so two lines are alternate, they must be equal. Okay, so y must be 124. Reason, alternate angles in the parallel lines. Okay. Next one is to see, say that is 124. So this reflex angle must be 124 times 2. Get me? So reflex of AOC is 124 divided times 2, which is eventually 248. And then how you find x? Yes, this is the angle at the point, which is 1 full turn, which is 360 degrees. So I take 248 out of 360. Okay, so this is x. So that equals 112 degrees. And then how you find z? Z is, what do they call those two angles? So these two parallel and the inside, cointeria. Okay, cointeria. So these two must be supplementary. Okay, so cointeria angles, which is 180 minus 112, you can see 68. Okay, so all you need to do, yeah, it's just a simple question. Okay, so again, internal angles subtended to the same arc, subtend to the center is double, double, and then angle subtended to the circumference is a half of the center angle. Okay, so that was question 9. 10. Find OQP. Find OQP here. We want to find that angle. Yeah, easy question. How do you do? Well, they are same radii, okay, equal radii. So these two base angles the same. So how do you do? Okay, OQ is OP, the same one. So therefore, 74 plus this should be 180. The reason is angle sum of a triangle. Okay, so OQ, these two the same. Then we can say this angle plus 74 must be 180 because angle sum of a triangle. Okay, then we know these two are equal. Okay, so move 74. Okay, take 104, 106. So that plus that is 106. So you can calculate it. So these two angles the same. They are equally 106 divided by 2, which is 53. Okay, so we find this angle is 53 here. So that is now 53 degrees. Okay, we may use this one to the next part. Part B, find RQO. Well, this small angle. What I like to do, please consider to see the big triangle, which is RQP. Okay, so angle sum of triangle should be 180 degrees. So that's what I like to see. Okay, have a look at this one. First of all, QRP is 37. So that equals to 37. 37. Reason is the angle at circumference is half of the angle at the center. So 74 divided by 2, you'll be looking at 37 degrees in angle. Okay. Next one, RQP. So RQP, so this whole angle plus 37 plus 28 and 53. So this should be 53, coming out 180 degrees in total. Okay. So this is what we can find the RQP. Okay, we can find once we find the RQP and subtract 53 out of it, then you will get that. Make sense? So RQP, so move everything to the right hand side, is coming out 62 degrees. Okay, so what's happening here? That equals to 62 degrees. So finally, the small angle, you'll be looking at 62 minus 53, which is 9 degrees. Okay, easy. Yeah, we just use the main thing for this question is 74, and then angle subtend to the circumference must be half of it, which is 37 in this case. Okay, so that was question 10. That's question 10. 11. Question 11. So find angle ABC. ABC, this angle, given AC is equal to AB. So these two sides are equal. So it's isosceles triangle here. Okay, ABC. How you find the first step is, well, you can find that angle, which is angle subtend from same arc to the circumference, which is half of 116. Okay, so that is 58. The reason is angle at circumference is half of the angle at center. Okay, so if you divide by 116, you'll be looking at this is 58 degrees. Okay, if you find this this is 58, well, we know they are equal. So this triangle ABC is an isosceles triangle. Makes sense. So what you can do, yeah, these two base angles are equal. So ABC, this angle plus this angle and plus 58, then you'll be looking at 180 degrees. Okay, but we know angle ABC and the angle AB the same. We just say 2 times angle ABC is 100 minus 58. What is that number? 112. You get divided by 2, you'll get 61. Okay, so angle ABC, that is 61 degrees at the moment. Next one, find the ABO. Okay, find the angle ABO, this angle. So how do you find that? Okay, how do you find that? That angle is so easy as well, because we can find these two base angle and take this one out of 61, then you'll get that. Okay, easy. So have a look at this one. BO is OC. So BO is OC. So this is telling about the triangle BOC is an isosceles triangle. Makes sense? Okay, and then OBC and OCB are equal because base angles of isosceles triangle. Okay. Now, angle sum of triangle, 116 plus this angle must be 180. You can say this angle the same, 2 times angle OBC plus equals to 100 minus 16, you'll be looking at 64. So divided by 2, that will be 32. So what is 32? that equal to 32. So how do you find the angle that we are looking for? Okay, 32 is subtracted to 61 is the bigger angle. You'll be looking at 29 degrees. Make sense? Okay, so that was 11. Easy, okay? It's just an easy application of single, double. Double angle, single angle. 12. Prove alpha is equal to twice of double of the angle theta, given these two angles are equal. Okay, there are a few things that you can do for this now. Well, again, this triangle, how about this triangle? Isosceles triangle because same radii. Make sense? Okay, so OPOR, radius, same thing. Therefore, what you can say, this must be theta. Okay, so because it's base angle of the isosceles triangle. Easy. Then, from the question, OPR, which is theta at the moment, is equal to QPR. So this must be theta, given from the question here. Make sense? So this question has given for you to use. Then what you can do here is R or Q, say R or Q, this angle should be double of that angle. What is that? So looking at this arc or chord, okay, say arc here. So arc QR makes an angle and a center angle alpha, and then makes an angle subtended to circumference. So this is double, this is single. Okay, so this is what it talks about. Therefore, it's double, single, so this is 2 times of theta. So that's what we need to prove. Understand it? Okay, so the important stuff for this question, okay, for this topic, no matter where you are with the angle, so any kind of arc, this is double, every time single. Wherever in the circumference, it's always single here. Okay, so that's what we just covered. Okay, so from next lesson, we're gonna do a little more than this one. Okay, I will see you at the next lesson, guys.